we'll be seeing the intuition. How do you know water can be trapped? For water to stay at position I, there must be a taller bore to the left and a taller bore to the right. So then only it will be staying. Water will be staying. At water, like at I, minimum of maximum left, comma maximum right minus total height of I. If we do this, then we'll be getting water. How much water does it will be left like that? Okay. So how does this work? Let's see. For example, this. If we see this, I is equals to 0, height is 4. Okay, height is 4. At I, the number is 4. That means I is equals to 0, height is 4. Nothing to left. That means left, no water. Okay, there is no water. Next, at I is equals to 1, height is 2. Tallest left, because at left side there is a 4. So it has a tallest left. Okay, tallest right is like 5. Okay, minimum of 4 comma 5 is 4. So water will be like 4 minus 2 will be 2 units. So 2 units of water will be stored. Okay, next, at I is equals to 2, there is a 0. That is left tallest height is 4, right tallest height is 5. Nothing changed, because here it is 2. 2 is not more than 4. So 4 is the tallest height from the left side, 5 is the tallest height from the right side. And if we do the minimum of 4 comma 5, we'll be getting 4. Okay, and the water is 4. 4 minus 0, it is 4. Okay, next, at I is equals to 3, the height is 3, and left tallest height is 4, right tallest height is 5. So minimum of 4 comma 5 will be 4. 4 minus 3 will be 1. Okay, 1. At I is equals to 4, we have height 2. Carefully listen. So water will be like taking left tallest is 4, right tallest is 5. As you know that 4 minus 2, it will be 2. So water is like 2 units. Next, at I is equals to 5, there is no right side. That means no water at right side, only left side. That is 4. That means we do not consider no right side, no left side. It is like at I is equals to 5. Here 0, 1, 2, 3, 4, 5. 5 is the last index. So no right side, no water. That's it. If there is no right side, then how can we store the water? Okay. And if we add the total, all the minimum values, then as I have told you, the actual formula is at index we'll be checking minimum of left, maximum left comma maximum right minus height of I. So according to the formula, if we add total water, 2 plus 4 plus 1 plus 2, that is 9. We'll be getting the output as 9. So if you go to the brute force, it's bad. Why it is bad? Because for each movement, go left to find max, go right to find max, it will be taking big O of n square, and it is too slow for the interviews. Okay, optimal solution will be 2-pointer technique. Now here the magic trick is, the best part of this problem to use is 2 pointers. That is, we'll be having one left pointer and along with that right pointer. Left will be coming from this starting, right will be at the ending. Okay, and 2 variables will be using, that is left max and right max. It will be checking which is the maximum at the left side along with the right side. So why? Because water can only be trapped up to the smaller of the two walls. That's it. So as you have seen this dry run, hope you have understood. But if you want more like this, I'll be going one more time. So if we take this again, listen again. So left will be like 0 index, left index will be 0, right index will be 5, because it is a length, whole length is 5. So left max will be 0, right max also will be 0 at the initial stages, like as you can see here. Water will be also 0. So height of left is like 4, height of right is like 5. Okay, it will be checking. Uh, it will be checking. First while condition will be left should be less than right. Okay, that is from 0 to n minus 1. Okay, it will go till there only, not equal to n minus 1 also, till less than n minus 1. So this is a while condition. If condition will be like height of left should be less than height of right, then only we'll be assigning height of left, tallest height of left to be the maximum left max and right max. Got it? Only then we'll be assigning left max to be the height of left. That's what. Otherwise we'll be assigning it to be the right max. Got it? This loop is about this. Then we'll be applying our formula. What we'll be doing is water plus is equals to, if we found that minimum of this left height and right height minus height of I said you that. So that is the formula we'll be applying in the two other loops. And after that, we'll be increasing left towards forward. And if it is happening with the right side, then we'll be decreasing right, because right pointer is coming from right side to left. So whenever we are moving from right side to left, we'll be doing minus minus. So that's what here it is happening, and simple, and we'll be returning water. That's it. That water means what? That is what? How much rainwater can be trapped into it. I hope you have understood. Let's run this code. So if I go with the intuition, you will be understanding in a great way. Not only that. Okay. So trapping rainwater looks hard, but here's a visual intuition. At every bar, water is trapped between the taller wall, is trapped between the taller wall to the left and the right. Okay, left and right, both are balanced. Okay. We use 2 pointers to track the boundaries and move inward. Always moving the side with the shorter height, because that limits the water. Okay, next we keep updating left max and right max, and if the current height is shorter, that difference becomes the trapped water. That's it. Okay, this logic gives you a clean big O of n time big O of one space solution, and solves a problem that almost every tech company loves to ask. Trust me, once you get this one, you will feel like a real TSA warrior. And imagine you are pouring water into between two walls, and water only stays up to the shortest wall, because if there is no boundary, if this is too long and if this is still here, then water only stays still here. That's it. It is like, what is the shortest? See, for example, this is too high, but this is still here only, right? Shortest one. So the water only stays still here. It can't fill this gap. Okay. So remember that kind of thing. So we always move towards the center from the smaller wall, and that's what makes two pointer method magic. So that's it, guys. Thank you so much for watching. This is a hard topic from this Leetcode questions. So do concentrate on this kind of questions and build your logic code by code, like one by one. We'll be solving it. Do subscribe my channel. Thank you so much for watching.